Thank you, everyone. So I'm Ansab, and this talk is mostly about parallel unit testing. But I would like to start with a like small word, and who has been laid off in their entire career? Anyone, or have seen some layoff in the recent past? Cool. So a couple of people. So the thing is, in tech world overall, in the last 2 decades, it's been a trend that we have spent a lot in engineering features. We did a lot of testing as well, and we didn't. We sort of build a infrastructure that is costing a lot to the companies, and eventually that was a bubble that was bound to burst. So this is something that I learned in the past couple of years: how to reduce your expenses, how to reduce the development costs, how to reduce the testing, and yeah, this talk is about that. And I would start with my introduction. So, good internet, but there was a picture of me over there. But I'm a software engineer. I work with edX. OpenEdX, you might know, is the biggest open source software based out of Django, also a Python framework. I also work with Agoda in the recent past. And yeah, most of my work revolves around architecture and expertise in testing. Also, I'm a data enthusiast. I don't think there's a surprise in that. And I'm doing a master's in data science from Langen. So yeah. And my other partner, Azan, again, no picture over here, he works at Amazon in their tooling team. He was my partner when I was working in edX and OpenEdX as well. And his work is also in tech, but it's mostly revolves around search engine optimizations. So he's a great guy, and unfortunately, due to some work, he couldn't be here. So everything that I'll be explaining over here is part of his work as well. So I would like to give him credit where it's due. So starting with two factuals. When you're creating an API out of DRF, Django REST Framework, and you're covering a basic CRUD, you're bound to write at least 35 unit test cases. So your code coverage revolves around 85%. It's the bare minimum code coverage that you can create. And the other factual is, in Django, on average, one unit test takes about 30 milliseconds to execute. So if you execute one API view in unit test, it takes approximately 1 to 1.5 seconds to execute completely. And I'll build on that. OpenEdX is one of the biggest open source Django repository. And it has over 5,000 unit tests in their biggest microservice monolith. And on average, it takes about 25 to 30 minutes to execute all tests, even if they're executing in parallel. So if you're working with monolith, this is a big challenge. And it costs, in Agoda, it used to cost about $190 per minute as an engineering cost. So if some tests take 30 minutes, you have to multiply 190 by 30, and that's your average cost of running one pipeline. This is a breakdown of the repo. So as you can see, by the way, this is an important slide, and I want you guys to take a good note of this data. They have a mono repo, and they have 5 different modules inside that. LMS, CMS, they have a common library as well. Some proprietary OpenEdX libraries and X modules. And you can see that average execution time takes about 20 to 25 minutes in the latest. And all of these tests are run individually, right? It used to be in series, so the total time took the sum of all of these tests in the start. So this brings us why parallel testing is important. So we're trying to speed up CI/CD pipelines. We're trying to reduce our expenses. We're trying to build scalable infrastructure without spending a lot of money again and again executing the same pipelines, the same CI/CDs. And yeah, we're trying to improve our execution timing of merging the code. So in big tech, there's a phenomena called MLTC, which stands for merge line time consumed or something like that. And it's a very big number for them, and it's like the starting point when you make the first commit in the repo till the time it's merged, right? And this is something that they want to spend the most amount of money on because they want to reduce their expenses. And on average, it takes more time to merge a code in the masters then it's required to build that feature, develop that feature. So it's a very big number for them. On average, I think Google posted a couple of years ago that their MLTC is somewhere around 1 to 2 hours, right? And for them, it's a very big number. So this is a sample build pipeline when you try to create this. You have a build pipeline, you have a linting pipeline, you have unit tests, integration tests, security tests. And this is a representation of how much time it takes to execute individually. And as much as it's important to cover all of these areas, I'm just going to cover the unit tests and how we can break that. But it's something that you can execute in other functions as well. So integration tests and security tests, you can also use the same knowledge to break those down, and hopefully it's a scalable idea. So typically, if you work with software, you would see something like this. This might be your build pipeline. So you have a build job, and then you have a linting and unit tests running in parallel. Linting mostly depends, like integration tests mostly depends on linting, and they execute security tests in parallel as well. So this is something that you familiarly see in your tech environment. But you can see that when we try to execute, we are sort of like saving some time, a little bit time. And sorry, one more thing. We're sort of like saving some time over here. And it's really important that this blue part you see, there's a huge gap over here. And this gap is something that we can work on. Similarly, after this integration test, we see this huge time lapse that we can improve on. So coming to series unit test, this is a sample of how unit tests are executed in majority of the applications around the world. There are different test suite. They execute one by one, and most of the flaky tests are because of this as well. So they all depend on each other for completing their executions, and all of them are executed in series. So it takes the time taken is like sort of the sum of all of these test suites. But what if we use the resources, common resources in the application, and we sort of use multi-threading and semaphores and other things offered by OS to execute all of the test suites in parallel? How much time can we save? So if we do that, I actually have a slide in the end which covers all of these performance. But right now, I want you to understand that we are sort of like closing on this gap that we have, which is really important, considering that this was the major point of concern for us. So the other idea is that we make all of these test suite completely independent. So that is somewhat what OpenEdX is doing right now. So every single microservice that they have built inside their monorepo, they have executed all of their unit tests individually. You can do similar things, create different configurations for each kind of application, and focus on executing their pipeline individually one by one, and they can run parallelly. And of course, you can run in GitHub, you can run in local as well. But of course, it's not going to run in series, so it's going to save a lot of time. And yeah, this is something it's going to look like. As you can see, we have unit test suite 1, we have other suite as well, and they can all run parallelly and individually, and they are not dependent on each other. And of course, we save a lot of time executing the pipeline as well. And as you can see, we have also reduced our difference to a point that it is almost negligible. So benefits of parallel testing. Speed is the #1 thing. It takes a lot of, it's very fast in building, it's very fast in executing unit test when in parallel. It's fast to translate this time in your development timelines, and you can reduce your MLTC considerably. And secondly, this is like kind of my experience as well. So I ran into a problem which was on production level, and we had to revert the code. But the code was taking a lot of time executing the unit tests, executing the integration test, and everything. So we sort of for hot fixes, we sort of had to, mute all of these tests for the execution timeline and deploy the hot fix. So it was not, it was like a security vulnerability in time. So if you're doing parallel testing and you're saving on your timelines, this is a faster time to recovery from an executable code. And of course, when you're scaling your application, you reduce your bottlenecks. You can apply multiple environments to execute your same kind of code and test your code in different environments as well. We can separate our concerns. We can build independent functions, independent services, and they can all be in the same microservice, monorepo, and they will all work independently. So it's a very important concept from parallel testing. What are the limitations? So the primary limitation is the cost of execution. When you're working with parallel testing and you're creating independent jobs, you're sort of creating an overhead in the pipeline. So if you're running one pipeline instead of 10, you're obviously saving a lot of cost over there. We have complex dependencies. This is a problem. So for example, you have a lot of microservices in a single monorepo. And all of these dependencies are there for each different microservice, and they're running their unit tests in series. They can all cause all sorts of problems, first of all, and secondly, they are all using common, resources that can, if there's a race condition, some resources are being used by some application. And I don't know, database is a good example. If there is a write operation being done on a particular row, and there is another unit test sort of using that row for execution of its own in Django, it can create a race condition, and it can create a lot of flaky tests. So ideally, you would want something of like a stable testing environment, so you don't have to run the pipeline again and again for failure. And lastly, there's optimization OCD. This is something like you create a lot of unit tests, and you create a lot of parallel testing environments. Optimization OCD is like you're sort of like driving it down to a point that it's almost negligible to optimize further, and you're still optimizing it, and it becomes a hassle, and like it's in a cost of its own. So yeah. This is a sample run of running parallel tests in Django. You can see this keyword -- parallel, which is offered in Django itself, and it will execute all of your unit tests in parallel by itself by default. So you don't need to do anything else except run this in your code. And as you can see, this is something you'll see that all of these processes are running all of these tests in parallel. And what are the results? Parallel testing in Django is 2 times faster than executing them in series. So if you run all of these tests in series, I ran OpenEdX over here. If you run all of these tests in series, you can see there are 591 tests, and it executes in 670 seconds, somewhere around 11 minutes, somewhere above that. And if you run them in parallel, the same amount of tests are run a little above 5 minutes. So it's almost like 50% reduction over here. And here's a graph. This is a very important graph. So this blue line you see, it's running unit test without using the parallel keyword in Django. And you can see that this drives up exponentially when you increase the number of unit tests over here. So right about 10,000 unit tests, you see that the difference between without parallel test environment, it's almost 10,000. It takes about 48 minutes to execute. And with parallel test, it takes about 23 minutes to execute, which is approximately 53% reduction. And then there are optimization aspects in this as well. You can use build caching to improve the testing environment. You can use build caching to use the same resources for multiple parallel testing environments. And if you run them individually in their individual suites, it sorts of become, a straight slope, horizontal slope, which does not, take more time than you want. So 48 minutes and 6 minutes, there's a huge difference, approximately 42 minutes. And yeah, more than 87% of runtime execution. And this is how it interacts in OpenEdX. OpenEdX, when we run all of these tests in parallel, you can see that the same results that we saw earlier, LMS, CMS, common. There's an average of about 45 to 50% of reduction in execution timelines. And it's they recently sort of like, moved to this, and it's been a very great success for them in the pipeline. So yeah, I kept this short for you guys, and if you guys have any questions, you can reach out to me on LinkedIn. And yeah.
Thank you, Asad. So we have a few questions in Slido. So the first one is about the testing time. How come the testing is only twice as fast with 6 times parallelization?
Sorry?
How come the testing is only twice as fast, even with 6 times parallelization?
Right. So Django takes a lot of resources to build. Like it's sort of like dependent on your environment, what sort of server you're using, what sort of operating system you're using. It should take little bit more time than, like less time than what he's mentioning, but yeah. It's mostly dependent on what sort of operating system and you're using, and this was the results on my. I was using Mac M1, so this was the result on my machine.
So the next question is about having a monorepo. So just a minute. If you have a testing time issue in a monorepo, would it not be easier to split the monorepo to different repos, is the question.
Again, it's based on your preferences, but most of the big tech, they want different products to be tightly observant and tightly coupled with each other, at least their code base. They want microservices for their improvement in like their deployments, but they want the code to be there for everyone to see in the same place, ideally. And it's a very big hassle for developers to push their code in different repos when they sort of like develop. So that's why it's a personal preference, but yeah, it depends on you.
So next question is, do you share test or data fixtures in the test database between the unit test suites, and how to avoid race conditions?
Right. So in Django, since Django is open source, there's already a lot of optimizations for race conditions, and in my testing, it's 0.01% chance that like 1 in 10,000 operations you'll run into race conditions. But ideally, when you're executing all of these test suites, that's why independent parallel testing exists, because all of these test suites have their independent resources to run and independent jobs. So yeah, if you're not okay with that 1 in 1,000 chance, 10,000 chance, then your preference should be to give different resources to different applications.
So we still have some time left. So I'll pass the mic on to the audience. If anyone has a question, just raise your hand.
No? Cool. Cool. Thank you.